Welcome to DSA Logic, your one-step solution for data structures and algorithms. I am Sheetal Chintanay, a senior software engineer at Walmart Global Tech. Let's see what we'll learn in this video. We'll learn to reverse an array using two-pointer approach, its time complexity and space complexity. Let's start. Let's take a simple problem and try to understand some important topics out of it. So, the problem we are going to take today is reverse an array. There are multiple ways to reverse an array. Let's take a look at one of them. Let's suppose this is the array we want to reverse. The first way we can do is we can take an empty array and we can iterate this original array in the reverse order, and we can assign that values one by one here, like 9, then 5, 5, then 7, then 3, then 1, and we are done. This approach, we are iterating once and processing each element once. So we can say we have a time complexity of O of n, where n equal to size of array. Now, this is a good solution, but can we do it better? Obviously, yes. Let's take a look at that one. So the original array. Here, what we are going to do is, in the first step, we are going to take the first element and the last element and swap these two. Let's swap it. So it will become like this. Now, in the next step, we are going to take the second element and the second last element and going to swap it. Let's swap it. And we can see our array is already reversed. So here we did one step and here we did the second step. Here we did total of n steps, but here in only 2 steps we are able to do. This is because this is depending upon the size of the array. Here we are doing actually n by 2 steps. So the time complexity here is O of n by 2. But technically it is again O of n. But if in an interview, if somebody asks you to reverse an array and you give this approach, definitely they are going to ask you if you can do something better. And this is the way to do it better. Even though the time complexity is same, but obviously we can see that this is going to take only n by 2 steps and where this is going to take n steps. Plus, here if we talk about space complexity, which is again O of n, because we are taking extra array to do the thing. Now, but here we are doing it in the same array. So the space complexity here is O of 1, which is basically constant space complexity. So obviously the way we should prefer is this one. Let's try to code this out. To code this, let's try to create a reverse method, reverse array. We need to pass the array to it. Let's pass it. And this method is good. Let's create this method. So now, as we saw in the approach when we were discussing, like we are taking the first element and the last element, then second element and the second last element. So we are basically using 2 pointers and swapping those two. So to code this thing, what we need is a for loop, Now this is having a I variable and some condition and the incrementer. Now for those who don't know, here we can take another variable also. Now, as in our discussion, we were discussing first element and the last element. So this is the first element index. Let's take the last element index, ARR of length minus 1. So this is going to be the last index. I is going to increment and j is going to decrement, because here this was going like this and this was going like this. What should be the condition? So if you saw, we didn't move ahead after this point once, because here j and I were going to be same. So we can say when till I less than j. So when this condition satisfies, we just need to swap the elements. Let's write the swap method. Swap var. Let's pass the array and I and j. And let's create the swap method. Now, to swap these two values in the array, what we need is a temp value in temp. Let's assign it with ARR of I. Now, as ARR of I we have already saved in the temp value, let's save the ARR of uh, j in the ARR of I place. Now, as ARR of j is already saved in the place of ARR of I, let's assign the ARR of j with the temp value. Cool, we are done. Now is the time to test it out. So to test it out, let's write a print statement. ToString and ARR. So this will print the array before reversing it, and let's print it after reversing it. Now let's try to run the program. Cool. Let's see. So this is the array before reversing it, and this is the array after reversing it. And we can say it is reversed properly. Now, when we write these kind of programs, we should always try to test it out with various scenarios. Let's try to modify the array a little bit and try to see how it works. So if you observe closely, this array has 5 elements, which is an odd number. Let's try to give it an even number of elements and try to see if it works correctly or not. So here is our output, and we can see like this also is reversed correctly. Let's try with one more time without giving any values to this array. Cool. You can see like we have our outputs here, which both the arrays are empty, which is expected because we didn't have any values over here. Now, as we can see, even after having the same time complexity, uh, this approach is more preferred. And in an interview, if somebody is asking you to reverse an array, so this is the approach mostly they are looking for. Now, what do we call this thing? This algorithm is called two-pointer algorithm. Now, two-pointer algorithm is rather than algorithm, we can call it a technique or whatever you want. But the key idea is to reduce the number of steps by using more than one pointers in the array. Because here the only difference was we had only one pointer, so we had to do n steps, and here we had two pointers, we were able to do it in n by 2 steps. This two-pointer algorithm is very much useful when we will be going to learn about linked lists. A lot of problems get solved very easily using the two-pointer algorithms in the linked list. Hope you liked it. If you liked it, please like, share, and subscribe. Thank you so much.